For question 1, let's firstly gather together the numbers. So that's 4 times 12, that's 48. 48 divided by 3, that's 16. Let's now think about the x's. X to the power 5 times x to the power 5, that's x to the power 10. X squared squared is x to the power 4. 10 take away 4 is 6. Let's think about the y's. Y to the power 4 times y squared, that's y to the power 6. That's a y squared. So y to the power 6 divided by y squared, that's y to the power 4. And finally the z's, z cubed, z squared, so that makes z. For question 2, the simplest way is to split this up. You could treat this as a quotient, but the simplest way is to split this up. So it's 2x over x to the power 1/3 plus 1 over x to the power 1/3. So x divided by x to the power 1/3, that's x to the power 2/3. And 1 over x to the 3rd, that's x to the minus 1/3. Now differentiating that is pretty straightforward. 2 times 2/3 is 4/3. So it's 4/3 x to the minus 1/3. And then we've got to differentiate x to the minus 1/3, so that's minus 1/3 x to the minus 4/3. Question 3 is a fairly straightforward integration. So we've got 4. X must have come from 3/2, so I need to divide by 3/2. And then I've got 5. That must be x to the power 1/2, so divide by 1/2, and that's from 9 to 16. So let's put in 16. 16 to the power 3/2 is 64, so it's 4 times 64 over 3/2. Then it's 5 times 4 over 1/2, so that's putting in 16. Let's take away 9. 9 to the 3/2 is 27, so 4 27 is 108. 108 over 3/2 plus 5 times 3, that's 15 over 1/2. And when you simplify that, that works out to be 326 over 3. Now for question 4 we need to write this as a single log, so let's write everything in terms of log to the base c. 2 to the power 4 is 16. That's c cubed, and the square root of 16 is 4. So now it's addition becomes multiplication inside the log, and subtraction becomes division. So it's log to the base c of 4c cubed. Question 5, the subtraction becomes a division inside the logs. The inverse of log to the base 3 is 3 to the power 2. So 4 minus x is 9x. So therefore 10x equals 4, and x is 4/10 or 2/5. Question 6 part A. We know that 1 plus tan squared is sec squared. So the 1's cancelled out, so we get tan theta minus tan squared theta equals 0. So tan theta 1 minus tan theta equals 0. So therefore tan theta equals 0, or tan theta equals 1. And then we get the solutions: minus pi, 0 and pi for tan theta is 0, and minus 3 pi by 4 and pi by 4 for tan theta equals 1. That's because the domain is between minus pi and pi. For part B, we've got a cos 2x here. There's 3 formulas for cos 2x, but let's use the one that just involves sin x because there's a sin x on this side. So we get 4 minus 12 sin x is 3, and the formula is 1 minus 2 sin squared x. So 4 minus 12 sin x is 3 minus 6 sin squared x. Let's get all the sine squares on the left hand side. This doesn't factorise, so sine x is minus b plus or minus the square root of b squared minus 4ac all over 2a. So from that we end up with sine x is 1 plus root 5/6, or sine x is 1 minus root 5/6. 1 plus root 5/6 is bigger than 1, so this equation has no solution, but the solution for this equation works out to be 0.0872, or 3.05 to 3 sig figs, and that's because x is between 0 and 2 pi. In question 7a, let's expand the left hand side. We've got 1 minus cos theta, 1 plus cos theta, so that's 1 minus cos squared theta. And 1 minus cos squared is, of course, sine squared theta. Now, cosec is 1 over sine, so that then becomes sine theta, which is the right hand side, therefore proof complete. In part B, the left hand side is 2 tan theta over 1 plus tan squared. Well, 1 plus tan squared is sec squared theta. So let's write everything in terms of sine and cos. Tan is sine over cos. Sec is 1 over cos, so that becomes cos squared up here. So cos squared over cos is 1, so we get 2 sine theta over cos theta. Sorry, cos squared divided by cos theta is just a single cos theta. It's not 1. It's cos squared over cos theta is cos theta. And so that's the right hand side, so proof complete. Now in part C, let's write everything over a common denominator. That's going to be sine theta plus 1 times cos theta. So cos times cos, so that's cos squared theta. And then it's sine theta plus 1 times sine theta plus 1, so that's sine squared theta plus 2 sine theta plus 1. Now cos squared plus sine squared is 1, 1 and 1 is 2, and there's a factor of 2. So it's 2 lots of 1 plus sine theta over sine theta plus 1 times cos theta. 1 plus sine theta is the same as sine theta plus 1, so they cancel. So that's 2 over cos theta, which is 2 sec theta, which is the right hand side. Proof complete.